Hello, everyone. My name is PENG WANG from the OceanBase global team. Over the past years, we've been working closely with users who are deploying OceanBase in Kubernetes, often across multiple clusters, availability zones, and even cloud providers. Along the way, we faced the big question: how do you keep a distributed database stable and high availability, not just in one cluster, but across many? That's exactly what I'm going to share with you today. This is today's roadmap, from the challenges of single cluster deployment to multi-clustered architecture and real-world benefits. Let's face it, depending on a single Kubernetes cluster is risky. Relying on a single Kubernetes cluster may seem convenient, but it comes with serious risks. The first one is a single point of failure. Any outage could bring down your entire database. It also makes upgrade risky, since everything happens in one place with no safety net. And it creates high maintenance pressure. Your team has to manage everything in one cluster, from storage to failover. That's why we started looking at multi-cluster deployment. Let's take a look at why multi-cluster makes sense. First, it enables true high availability. Your database can survive even if an entire cluster goes down. It improves disaster recovery and helps you avoid regional failures, especially in multi-available zone or multi-cloud environments. It also supports smooth Kubernetes upgrades, since clusters can be updated independently. And in the long run, it lays the foundation for hybrid cloud architecture, giving more flexibility and resiliency. Before diving into our deployment mode, let's have a quick look at OceanBase. OceanBase is a distributed SQL database designed for high availability and strong consistency. It uses Paxos protocol to ensure consistent data across replicas. A typical cluster has 3 OceanBase available zones, each storing a full replica of the data. Each OB zone contains multiple OB servers, and each OB server holds part of the dataset. To manage OceanBase in Kubernetes, we built a dedicated operator. We use custom resource mapped directly to the OceanBase internal architecture. At the top, there is an OB cluster, which manages the entire system. Then, we have OB zone, which represents the zone holding one replica of the data. And finally, OB server, which manages the pods, storage, and services for each data node. The operator takes care of syncing change across resources and making sure everything stays in sync at the Kubernetes level. When deploying OceanBase across multiple Kubernetes clusters, a natural approach is to place each OB zone into a different cluster. But here is the key. We don't need to define OB zone or OB cluster resources in every cluster. Instead, we define and manage all the custom resources in the master cluster. This is where the OB operator runs. The other clusters, called worker clusters, only runs the OceanBase workloads without needing any OceanBase-specific CRD. To make this work, we use a custom resource called Kubernetes cluster to store credentials and connect information for each work cluster. The OB server controller in the master cluster uses it to manage native Kubernetes resource remotely. This design works really well in practice for a few important reasons. First, it's simple. With one control plane, you have a single place to manage and monitor the entire deployment. Tools like Prometheus can easily discover all components. Second, The worker clusters stay lightweight. They don't need to run OceanBase operator or install any custom resources. And third, it's resilient. Even if the master cluster goes down, the worker cluster keeps running without any interruption. You can always recover the control plane by restoring the master cluster from backup. We first built this for custom running apps in multi-cloud clusters. They needed a database that could stretch across different clouds, and OceanBase fit the bill. In the real world, this architecture helps users tolerate failures even at the cloud provider level. It's designed to deliver high availability and disaster resilience, not just within cluster or region, but across clusters, zones, or even clouds. To wrap up, multi-cluster deployment of OceanBase on Kubernetes gives you stability, scalability, and simplicity. It's a clean and cloud-native design that's battle-tested in production. If you are interested, feel free to catch me after this talk. We'd love to hear your story. And welcome to join our OceanBase Discord community and subscribe our YouTube channel. Yeah. Thank you, that's all.